acoustical, natural materials, reliability and maintenance. Dr. Fatima holds a PhD and master's degree from the Indian Institute of Technology, Kharagpur. She is a recipient of the DST Inspire Faculty Award and Young Professional Award from International Institute of Noise Control Engineering. She was a postdoctoral fellow at the Ray W. Herrick Laboratories of Purdue University, United States of America, under the Schellenberger Foundation Faculty for the Future Award before joining Indian Institute of Technology, Delhi. She has wide experience in NVH, industrial noise control, machinery health monitoring, and has received several international and national awards for her research area, noise control. Okay, so this is a brief profile of our distinguished speaker, Dr. S. Fatima. Now I invite our speaker to start her lecture, and she can also share the screen. Before starting the lecture, I request all the participants that if they have any query or question during the session, so they can post their questions and queries in the chat box. Okay? And these questions will be addressed after the session is over. Okay, so all the participants remains muted during the whole session, and we will take up the questions from the chat box, and that will be answered by our distinguished speaker. So again, I welcome our distinguished speaker, Dr. S. Fatima. Please continue, madam.
Thank you, Professor Rahman, for the nice introduction. I hope my screen is visible to you.
Yes, yes.
Okay. Can I start?
Yes, please, madam, you can start.
A very good morning to all of you. And in today's lecture, I'm Dr. Fatima, and in today's lecture, I'm going to discuss some concept of maintenance and reliability. So here is the outline of my presentation. First, I'm going to introduce you how reliability and maintenance are interconnected with each other. What are the different maintenance philosophy, how to proceed with one philosophy, what kind of maintenance we should do, what is reliability centered maintenance, why reliability centered maintenance is important to us. And again, I'm going to discuss how to do a data analysis and reliability evaluation, how to calculate the reliability of any component, machinery, how to find out the reliability, how to find out the life of the system. And in the end, I will discuss you with the case study, emerging trend in condition monitoring. Yes. So as we all are aware that maintenance is all activity involved in keeping a system, equipment in working condition. And what is reliability? Reliability is basically the probability of a machine or element to perform its intended function under stated operating condition within a specified operating condition and a time period. Reliability is a very important factor in equipment because because if we want to increase the reliability of any component or machinery, we have to perform some maintenance tasks, and we have to decide when to do those maintenance tasks. So by doing those things, we are able to increase the reliability of machinery and maintain it for a longer period of time. So reliability is an important parameter in equipment maintenance. So before I proceed with the things, I just want to discuss the basic terminologies, basic terms used in reliability. One is failure. What is failure? Failure is basically an event when an item is not able to perform its intended function. Failure rate is a number of failure per unit of gross operating period, time, event, cycle. And what is mean time between failure? Because we are trying to maintain the system. And here we are talking about a reliability or the availability of a mechanical component or mechanical component. Those are repairable in nature For that, mean time between failure is calculated. Basically, mean time between failure is the average time between failure occurrence, the number of items and their operating time divided by the total number of failure. Mean time between the failure is basically for the repairable item. Mean time to failure is basically for the it actually used for the repairable as well as non-repairable items also. Non-repairable item means electrical and electronic component which cannot be repaired. So for those components, we calculate the mean time to failure, the average time to failure occurrence. Next is mean time to repair. So here we also calculate how much time is required to repair, restore the item to a specified condition. That is known as mean time to repair. Maintainability, repairability, maintainability, availability, these are the terms which are used very frequent and people are basically get confused by all those three terms. Maintainability is defined to be the probability that a failed component or system will be restored or repaired to a specified condition within a period of time. So when maintenance is performed. Availability is actually the right term to be used with the repairable component, because every time when we are talking about a repairable component, we are actually not looking for the reliability, because reliability is something which is associated with the non-repairable component, and availability is something which is related with the repairable component, because we want to know whether at that period of time the component is available to use or not. So that is known as the availability. It is defined as the probability that a component or system is performance is required function at a given point in time when used under a stated operating condition. So in all the things, we are actually discussing about the types of the failure. In mechanical component, what could be the type of the failure? There are two most common type of the failure. One is known as sudden failure, that is basically due to some stress which exceed the strength of the product, or which actually exceed the strength of the equipment or the machinery. Next important terms, that is known as degradation failure, that is known as the gradual wear out. Degradation indicators such as crack growth, change of resistance, corrosion, and due to aging also. So in sudden condition, we can't do anything with the maintenance, because that is sudden act of the God, or there are any other factors also. Sometimes the current increases, or there are other so many factors which is associated with the sudden failure. So we don't have any control on the sudden failure, but most of the component which actually encounter degradation failure. So for degradation failure is the ideal condition for any types of the maintenance, or it is ideal for condition-based maintenance also. And the other failure may also occur in the system, that is because of the human error also. So reliability is basically life to death phenomena of any component. So initially, each and every component has to face these three different phases. One is burn-in phase, second is useful life, third one is wear out. So burn-in phase is basically a decreasing failure rate, where we look into the possible causes of failure because of manufacturing defect, welding, soldering, assembly defect, or error in the part, or poor workmanship. So these are the possible causes of the failure in the burn-in phase. If you look into the useful region, so useful life, the failure rate is known as the constant failure rate. Here, failure can only occur because of the environment condition, random load, human error, or you can say sudden failure kind of things. But after third phase is known as wear out phase. That is actually the degradation region. Here we face increasing failure rate because of wear out, degradation, fatigue, corrosion, aging, friction, etc. So by doing the maintenance, we are actually we are trying to do in this. How we are going to relate machine reliability with maintenance. So actually, by performing the maintenance, any types of maintenance, we are trying to achieve maximum useful life of any component or product. So basically, we are trying to stretch out the useful region of any product. But as we all know that all products have some inherent reliability. as I can discuss with a simple example, as we all are aware that human life is for so many years. By performing all the types of maintenance, or by going to doctor, or by taking a lot of care to your body, you are only extend to certain years only. So similarly, the same phenomena is applicable to machinery also. The inherent reliability is actually based on the material properties. So if the material is composed of that material which can certain which have a certain life, then your product is also having a certain life. So you can only stretch the useful life by doing the maintenance to certain years only. You cannot by doing the maintenance, you cannot exceed the life to an infinity. So that is also for a certain period of time only. So if you look into the bathtub curve, the failure rate of mechanical systems start increasing from the beginning, where it is constant in the electrical and electronic system. So degradation, failure, and maintenance. So here are the. So what is machine availability? Machine availability is basically the uptime upon total time, or you can say uptime plus downtime. So now, so what is the major problem? So what we are facing in the useful life is unexpected breakdown. If we talk about any plant, or you can talk about any machinery or any product, those having a mechanical component, we are facing unexpected breakdown. So here, if you have a plant like this, sewage treatment plant, where there are so many units, if you talk about it's having a preliminary treatment plant, primary treatment, membrane, end product. So this is a total plant. And if you talk about a big machinery, you can look into the surface minor. There we can see there are a number of components. So if we face any kind of unexpected breakdown, how to maintain that system? Or is there any other way to figure out the maintenance before it's actually happened? So here, the major problem is unexpected breakdown. So by doing the maintenance, how we can mitigate the how we can reduce the effect of the breakdown, or how we can minimize the effect of breakdown. So by looking into the definition of maintenance, maintenance is basically the combination of all technical and administrative action, including supervision action intended to retain an item, restore it, state at which it can perform a required function. This is the standard definition of maintenance. Maintenance is basically a set of organized activity that are carried out in order to keep an item in its best operational condition with minimum cost. See, every time whenever we talk about the maintenance, we will also look into the cost of maintenance also. See, cost of maintenance cannot exceed the cost of the product. So every time we have to look into the cost of maintenance also. So if you look into the history of maintenance, so maintenance start from 1940s, or you can say the first generation of maintenance. In that time, what we do is, once the system fails, we try to maintain it, fix it when it broke, or run to failure kind of strategy, or you can say breakdown kind of maintenance people was doing. In second generation of maintenance, people are trying to schedule the maintenance activity, or schedule the monitoring of the system, or you can say scheduling the overhaul, or based on doing some cycle kind of activities, they are looking into the maintenance. So here people are performing preventive maintenance. In third generation of maintenance, due to the advancement in the technologies, people have started using transducers and find out the actual condition of the system by performing condition-based maintenance, or you can say condition monitoring, or you can also say that predictive maintenance. So here people are looking for higher plant reliability, equipment life extension, because before its failure, people are trying to predict the failure by mounting some sort of sensor, by continuously monitoring the system also. Here people are also looking into design for reliability. People are also looking into failure modes and effect analysis, that I will discuss. Condition monitoring. Now we are in the fourth generation of maintenance. Here we want to know why the system failed. Can we use those kind of technology where we can extend the life of the things also? So here we are actually performing the maintenance, but here also we are finding out the root cause of the failure also. So right now we are in the fourth generation of the maintenance, where we also are trying to look into the root cause of the failure and trying to mitigate those root cause also. So what are the basic objective? We all know that basic objective is maximizing production, minimizing energy usage, optimizing the useful life, looking into the budget also, optimize the maintenance activity, optimizing the resource utilization. And by doing those, what we actually achieve is reduce breakdown, reduce downtime, improving equipment efficiency, improving inventory control, implementing cost reduction. So we all are aware about the maintenance objective. Now, as I told you, we have 4 different types of maintenance philosophies. One is breakdown maintenance, that is also known as reactive maintenance. We wait for the system to fail. Once the system fails, we fix it. Next is preventive maintenance, that is known as periodic maintenance because it is based on some period of time or schedule or calendar or runtime or number of events also. So that is known as the preventive maintenance. Third one is known as the predictive maintenance, that is the condition-based maintenance. By mounting some sensors on the machine, we are actually trying to predict the condition of the machinery. Fourth one is proactive maintenance. Here, this is the 4th generation where actually we are trying to identify and design out the root causes of failure. So I'm going to discuss one by one in detail. In breakdown maintenance implies that repair are made after the equipment is failed and cannot perform its normal function anymore. So breakdown maintenance, nowadays also people are using breakdown maintenance because it is quite justified in small scale industry where the system are not critical. So system are basically divided into 3 categories. One is critical component without which the things will not perform. Next is essential. So essential is also very important, but here we can perform the actual production things without this. Fourth one is general purpose equipment. So for the general purpose things, breakdown maintenance is quite justified. For the essential equipment, we are looking for preventive maintenance as well as breakdown maintenance. And for the critical component, because suppose if we take an example of a steel plant, if in a steel plant, if the blast furnace is not working, you are not able to produce anything. So here the blast furnace is actually the critical component of a steel plant. If we talk about a pump, so there are a number of pumps in a steel plant. If one pump is not working, I know that is essential component. The pump is very essential in steel plant. If one pump is not working, we can still perform the function. So that pump is known as essential component. Suppose there is a water cooler in a steel plant and that water cooler is not working, that is for the manpower. So if that is not working, you can still perform your intended task. So that component is actually known as the general purpose. So for general purpose, we can go for breakdown maintenance. For essential, we can go for preventive maintenance. For critical component, we can go for predictive maintenance or proactive maintenance. So next is preventive maintenance. It is a set of activities that are performed on plant equipment, machinery, and system before the occurrence of failure in order to protect them and prevent or eliminate any degradation in operating condition. So it is good for the machine and facilities which their failure would cause serious production loss, because preventive maintenance is also associated with cost. Every time you are performing some task to maintain the system. If you talk about automobile, so every 6 months or a number of kilometers, you have to perform your preventive maintenance things. You have to change the filter, you have to change the oil. Sometimes it is quite justified, but sometimes your oil condition is good and still because OEM has told you that you have to change your oil after certain period of time, you are changing your oil without looking into the oil condition. So in that case, you are actually wasting the money, correct? Because your oil is good as it was, but here you are changing the oil because as per your OEM, you have to change it after 6 months. So that is actually counted as a loss in the maintenance. So it is good for those machines, but if you talk about our defense or the army activities where you have to use a missile or where you have to use a tank, in that kind of machinery, because there the critical is the person who is going to operate that. During the war, you are not looking into the money side, you are actually looking into the working of the equipment. So, or if we talk about an aircraft, if in aircraft people are performing number of preventive maintenance activities, in that case the preventive maintenance activities is quite justified, because if the engine is not working, so your aircraft will crash. So in that case, the preventive maintenance is justified because the critical is the life of the person who is in the aircraft. So for that, some condition, the preventive maintenance is quite justified. So the aim of preventive maintenance is to maintain machine and facility in such a condition that breakdown and emergency repair are minimized. So what are the major activities in preventive maintenance? Is actually replacement of the equipment, adjustment, major overhaul, inspection, and lubrication, cleaning. So these are the actual activities in the preventive maintenance. Now we move to the predictive maintenance. Predictive maintenance is a set of activity that detect change in the physical condition of equipment. How it can detect? Because we are mounting some sort of sensor on the machine. Sensor can be in form of vibration, temperature, motor current signature analysis. So all the different types of predictive maintenance techniques we are going to discuss in detail. So in order to carry out the appropriate maintenance work for maximizing the service life of equipment without increasing the risk of failure. Without increasing the risk of failure means here we are actually continuously monitoring the system condition. So if you talk about the techniques of our predictive maintenance, there are different techniques: vibration, wear debris analysis, where we monitor the oil condition or the debris, oil, temperature, electric current, process parameters. What are the benefits of predictive maintenance? By performing the predictive maintenance, it's actually, there are a number of benefits of doing predictive maintenance. Lower maintenance cost. Equipment cost is quite high in doing the predictive maintenance, but if you look into the number of years, and if you look into the in a longer span of time, predictive maintenance is actually lower maintenance cost, fewer machine failure, because actually you are continuously monitoring the machine. So before the failure occurs, you can change it or repair it, or you can plan your maintenance activities. Less repair downtime, reduce small part inventory here, because you know that this system will fail after so many hours of operation. So beforehand, you can order the inventory also. You don't have to keep the inventory in an idle state. Longer machine life, increase production, improve operator safety also. Condition-based maintenance can be actually applicable in very wide range: power plant, process industries, offshore, aerospace, automotive, ship, earth moving, mining equipments. So I'm going to discuss the machinery condition monitoring for different types of machinery condition monitoring techniques. First is vibration-based monitoring. So in industry, 70% of the machinery condition monitoring are actually carried out by doing the vibration analysis. Here we bound the transducers at different location, monitoring the vibration, and based on the acquiring the signal out of that transducer, we are actually finding out the characteristic frequency, and based on those characteristic frequency, we are able to say what kind of fault is there in the system. Second important thing is wear debris analysis. This is not an in situ kind of measurement. Here we send the oil sample to the respective lab, and we tell the person that you have to perform this type of test on the oil sample, and by doing that he is able to tell us the composition, what are the impurities are there in the oil, and based on those particle or the impurities we are able to tell what are the failure in the parent material composition to be known. Other important techniques are used 10% in industry, that is known as thermography, ultrasonic, and motor current signature analysis. So I'm going to discuss all the different types of techniques of condition monitoring. So vibration monitoring is a key predictive maintenance technique. It is used to determine the operating and mechanical condition of equipment. And here we can conduct the vibration monitoring at regular interval or a continuous base or a schedule interval based also. Here we measure the amplitude of vibration at different frequency, as we all we know. Looking into the rotating frequency, we can calculate the characteristic frequencies of different components also. And looking into the rise in the amplitude of those component characteristic frequency of those component, we are able to tell what kind of fault is there in the system. So if you talk about any rotating machine, so what are the major component in a rotating machine? In a rotating machine, there are a number of components like bearing, gearbox, shaft, impeller, coupling. So these are the various components of a rotating machine. If we talk about what are the fault associated with those kind of rotating machine, so the fault are misalignment, unbalance, bearing defect, gearbox defect, shaft cracked shaft. So these are the major fault of the rotating machine. And by looking into the characteristic frequency of unbalance, or by looking into the characteristic frequency of misalignment, or by looking into the bearing defect frequency, or by looking into the gearbox defect frequency, we are able to tell what kind of fault is there in the system. So here we can detect, identify, and diagnose the problem in equipment. See, on the left side, there is a cement mill where we have a number of rotating components. So basically what we do is we just go mount the accelerometer, acquire the signal, and looking into those signal and the characteristic frequency, sometimes the signal get modulated by amplitude modulation or frequency modulation. So we have to apply some sort of signal processing techniques, and then looking into those, filter out the signal, and looking into those signals characteristic frequency, we are able to tell what kind of fault is there in the cement mill. Here on the right side, I'm actually monitoring the human body vibration. Human body vibration is also very important because vibration monitoring can also be used for designing the equipment also. Here we are actually looking, we are actually taking the data of the how much the body is introduced with the vibration. So here, once we know, we can perform different kind of road test at different roads, and we get to know how much shock is going to absorb by the shock absorber. So here we can, in the later stage, we can tell the OEM that here the body is introduced with so many amplitude of vibration. So we can reduce those amplitude by improving the design of the shock absorbers also. So here we are performing a human body vibration. So vibration can be used for design stage also. Now come to the fundamental of signal analysis. So suppose we mount a transducers on the system, or we can say we mount an accelerometer on the rotating machine, maybe on the bearing side or maybe on the gear side. So what we do after that? So we acquire the signal. So instantaneous signal is measured by sensor as a transducer, and the analyzer process the signal to given frequency and time domain. So first we acquired the time domain signal. Suppose I ask you how you are going to analyze those time domain signal, because that is on the time scale and we have an amplitude. So we can extract some features on that time domain signals also. That feature can be in term, if you have an array of signals, what we can acquire? We can acquire RMS, skewness, kurtosis, correct factor. So these are the feature, these are the statistical feature which we can take out from the signal. So looking into the time domain features, are we able to figure out what are the different kind of fault is there in the machine? Because sometimes looking into that time domain feature, it is very confusing. We are not able to come to any conclusion by looking into the time domain features. So for that reason, we have to convert those time domain features into frequency domain feature by using the FFT technique, fast Fourier transform techniques. So frequency domain shows the frequency versus amplitude value. So the DFT and FFT are the technique used to convert the signal from time domain to frequency domain. So once we have a frequency domain signal, so these are actually the time domain signal. These are the signal characteristic. What we can get is range, mean value, root mean square. These are all the statistical parameter. You all know that. Variance, standard deviation, skewness, kurtosis, crest factor. These are all the statistical parameters. I'm sure that in your 10th or 12th you have done this kind of exercise. So with time domain, we are not able to find out what kind of fault is there in the system, whether it is because of misalignment, unbalance, bearing, gearbox. So for that reason, we have to convert those time domain feature into frequency domain by performing FFT. It is usually signal is described as a function of time. Analyzing the signal in the frequency space provide amazing advantage because it converts the signal into frequency domain, and by looking into the frequency domain and its characteristic frequency, we are able to detect the fault. So how we do this real time measurement? Mounting the accelerometer on the product. So here I am monitoring the railway vibration in railway engine vibration by mounting the accelerometer on the floor. And we are acquiring the signal. Here we are acquiring the 4 signals. We have mounted actually the 4 accelerometer on the surface, and we are acquiring the data, and we are monitoring we are doing the real-time monitoring of the signal. Next important, so I'm just giving you a glimpse of all the techniques. I'm not going into the detail because I'm sure in previous lecture you have gone through bearing health monitoring, and in the later stage you are also going to look into the gearbox health monitoring in detail. So I'm sure in that lecture you have covered. So I'm just giving you a glimpse of all the techniques. So next important techniques is wear debris analysis. So what is wear debris analysis? When two mating surface rub against each other, it actually produces friction. So for reducing that friction, we are actually introducing some sort of lubricant. Okay. So even with aging, some particles start coming out from the surface and get deposited into those oil or the lubricant. So the contaminant which comes out is known as the contaminant analysis. How we can do those contaminant analysis or wear debris analysis? We can perform different kind of tests. First is particle count test. So here we are looking into the certain number of particle and say this is the particle part per million is that much. And based on that, we are able to say, we are able to look into the severity of the defect. We are able to look into the composition of the wear. We are also looking into the morphology also. Next is ferrography, because most of the rotating component are made up of maximum contribution is from the ferrous side. So here we do the ferrography, where we look into where we collect the data on the magnetic strip and find out the intensity of the failure. Next is spectroscopy. If the particle size is less than 2 microns and we are not able to find out any ferrous particle and there are other particles also, in that case we are actually performing the spectroscopy analysis. So there are a number of ways, there are a number of techniques of spectroscopy, advanced techniques of spectroscopy, where you can get to know about the morphology of the component, or basically we can say elemental analysis of the particle. Next is oil, because in oil, virgin oil is different, but something get fused in that oil, the oil will change its property, its viscosity and other properties of the oil. So by looking into the oil condition also, we are able to tell what kind of fault is there in the parent material. So if in oil, if we found a ferrous, we can say that ferrous particle is because of the rolling element bearing, or we can say that is from the gearbox, or we can say that is from the piston side. If there is nickel, molybdenum, or borium, or any other type of a particle we found in the oil, we can actually relate with it with a parent material. So in wear debris analysis, we can look into the quantity. Based on the quantity, we can get to know the severity of the failure also. Looking into the size, rate of the particle, whether the size is small, big, or boulder size. So based on that also, we can say morphology. So we all have machined the steel and the cast iron. We know the chip of the steel, stainless steel, is different from the chip of the cast iron. So here, looking into the chip, you are able to tell this. The parent material could be the cast iron, or parent material could be the stainless steel. So here, based on the chip formation, we can also tell what kind of what could be the parent material. Next is the composition, looking into the source, elemental analysis. So element in spectroscopy analysis, once you analyze by performing this spectroscopy test, you can get to know what are the wear element. If you talk about a wear element, the wear element can be of iron, chromium, aluminum, copper, lead, nickel, magnesium, titanium, silver, and molybdenum. Additive, because for increasing the oxidation of the, for reducing the oxidation of the oil, we will add some sort of element in the oil, that is zinc, phosphorus, calcium, barium, magnesium, sodium, and boron. Contaminant, because all the machineries are at different locations. Suppose I talk about equipment which is performing some job at mining industry. So mining industry is exposed to dirt and dust. So the contamination could be silicon. If the equipment is in the paper mill, the contaminant is different. If the equipment or the machine is at this cement industry, the contaminant is different. So by looking into the possible source of element detected by spectrometric analysis is, if we found aluminum. So aluminum, the probable origin of aluminum is piston, bearing, turbochargers, pump, vane, thrust washer, impeller, rotor. Chromium, ring, bearing, liner, copper, bearing, iron, cylinder, crankshaft, piston, bearing, cylinder. So these are the possible origin. Lead, molybdenum, tin, bearing. So by looking into this, we can say what is the probable origin of the system. Next is example of contamination. As I told you, if it is a mining industry, the maximum things are from the stone, dust, or water. If it is a process plant, the contamination could be process material, dust, water, chemical. If it is a quarrying industry, stone, dust, component manufacturing industry, cutting fluid, dust, water. If it is a steel making, mill scale, dust, water. If it is a ceramic, clay, chemical, dust. So these are the example of contamination. So an effective oil analysis program should have an established objective and an oil analysis schedule. So in this, handle the oil sample very correctly. So oil analysis is actually similar to blood collection. So in a human body, what we do is we take out the blood sample and we tell the person to perform this kind of test. We want to know the hemoglobin, or you want to perform a COVID test or some other test. You have to tell the person, the pathology person who came to collect our test, he handled the bottle very carefully. He can take out the blood from a very clean or a new syringe. So in a similar way, we have in this oil and in handling the oil sample also, we have to take a proper care also. Proper communication with the analysis lab. Similarly, like in our blood sample, what we do, we tell the person to perform this kind of test, we look into the result, and then we perform the extended test. So in a similar way, we do it here also. Understand the different oil analysis trend, put the right oil in a right machine, extend oil drain interval when needed, identify the quantity of contaminant, identify the origin of contaminant, provide feedback to the laboratory, evaluate the cost effectiveness. So these are the major steps to perform for effective oil analysis program. So the third important technique is ultrasonic. Ultrasonic technique, here we send the signal which is greater than 1 megahertz, and we send the signal and we receive those signal. In delay, by looking into the delay of the signal, we can tell what kind of crack is there in the system. This is actually required. It is very important test to perform after welding, or you can say if someone want to monitor the railway track. If someone want to monitor the railway track, whether there is any crack on the railway track, this type of technique is used. That is known as ultrasonic. So high frequency greater than 20 kilohertz, which is greater than 1 megahertz, are used. Speed of ultrasonic wave is different in different material. Wave intensity decreases after a certain depth. Suppose if we want to monitor the pipeline defect, how you are going to, by doing the vibration analysis, you cannot find out the pipeline defect. So you have to use some other technique, and that technique is actually known as ultrasonic. So by sending and receiving the signal and decaying that signal, we are able to tell what kind of the variation is in the signals. Fourth important technique is, I can show you a video also on ultrasonic. Wait a second. Yeah. I hope the video is visible to you. So here we have performed the welding on this plate, and now we want to know where the crack is. So if you look into the side, we are able to find out at what location the crack is, at what depth the crack is. See, so this is a very important technique and have a very specific applications also. Here, I already told you that it is mandated to do ultrasonic after performing the welding. We can get to know the crack. Next important technique is motor current signature analysis. So it is similar to vibration based analysis. It is an online offline analysis technique which include instantaneous current measurement. So similar way, like we are doing the vibration monitoring, we are doing the current monitoring. Why it is required? Because in some application, we are not able to mount the transducers. In those applications, what we do is we actually mount the, take out the current signature, and based on that signature, we are able to tell what kind of fault is there in the system. So here, in terms of transducer, the Hall effect sensor is used and an analyzer for analysis. Motor current signature analysis can be used in those situations where accelerometer cannot be mounted, such as submersible pump, because submersible pump is below the ground, and in that condition, we are not able to mount accelerometer on the surface, or we cannot perform ultrasonic test, or for the submersible pump, we cannot perform oil monitoring test. So in that condition, how we are going to monitor the condition of the submersible pump? So this is the technique which can be used to monitor the condition of submersible pump. By this analysis, the fault can be detected, like detection of broken rotor bar in a pump, static and dynamic eccentricity, mechanical unbalance, bent shaft, bearing irregularities, impeller defects. So this is the submersible pump, which is actually submerged in water. So here we mount we are acquiring the signal of at the power cable, we mount this Hall effect sensor and looking into the current draw, and that features tell us whether there is any fault in the system or not. So here we perform we actually introduce the defect in the impeller. We remove one impeller, then we remove second impeller also, and looking into the side band of the characteristic frequency, we are able to tell that there is an impeller defect in the system, submersible pump. Now, the fourth important technique is thermography. Here, we all know that every body emits some sort of thermal radiation. Okay, but that thermal radiation is not, we cannot see those thermal radiation with the naked eyes. So we acquire, for that, we require to use some sort of sensors, and that sensor is known as thermal imaging camera. In thermal imaging camera, why it is able to detect those kind of thermal radiation? Because it convert those radiation into heat, or you can say convert it into electromotive force, and by looking into those thermogram, we are able to tell where the fault is. Thermal radiation is a form of electromagnetic radiation. All object will emit thermal radiation. Our body also emits some sort of thermal radiation as a consequence of their temperature. So thermal radiation occur beyond the visible infrared visible light. Visible region is this, infrared region is this short length, and then in the electromagnetic spectrum. Radiation energy and temperature. Camera detect electromagnetic radiation in a certain wavelength. To measure here with the camera, we actually trying to measure the temperature. But how we can measure the temperature? Because a scientific law is actually relate the temperature to radiation energy. We are actually trying to detect the radiation it tells us how much radiation a black body at a certain temperature will emit. The phenomena which actually convert radiation to temperature is known as Stephen-Boltzmann's law. Stephen-Boltzmann law states that total energy radiated per unit surface area of a black body in a unit time is directly proportional to the fourth power of the black body. So here, the Stephen-Boltzmann's law relate with the black body, but in general, we encounter only the real body, not the black body. Because black body is a theoretical term, and in practice, we only encounter real body. And camera only get radiation from the real body. So hence, Stephen-Boltzmann law for real body will be this. Here we introduce one more new term that is known as emissivity. It is the ratio of radiation emitted by a real body compared to the radiation emitted by a black body at the same temperature and same wavelength. So if you look into the emissivity of different things, thermal and electrical insulator are excellent emitter. Wood, rubber, plastic, paper, concrete, painted surface, building. But if you talk about a metal are poor emitter, hence heavily oxide. Emissivity is rarely superior to 0.25. Copper, steel, iron, brass, nickel, zinc, aluminum, lead, chromium. So if we want to measure the emissivity value of those things, or if we want to measure the temperature or take out the thermal image of any metallic surface, which is actually a poor emitter, we have to calibrate the camera. So IR cameras are calibrated to black body, so only black body radiation can be converted to temperature. Here also in normal camera, we focus the lens. Here also we do in a similar manner, looking into the temperature, relativity, humidity, focusing, image composition, temperature range. Here we also do it in a similar manner. So how this camera, this particular thermal imaging camera is different from our normal camera, because in this camera we are having a semiconductor which actually convert the radiation into to temperature by using that Stephen-Boltzmann's law. So calibration of the camera, because putting a right value of emissivity is actually important to measure any image of the any thermal image. So for that, the calibration of the camera can be done by two ways. One is field calibration. In field calibration, select a temperature, select a sample, a known temperature sample, and move your measurement function to the sample surface. Measure temperature with particular emissivity, because here the temperature is known to you, so you can change the emissivity accordingly, and note that particular emissivity also. In other way, what we can do is, because for the black body, we all know the emissivity value of the black body is 1. So we put a black tape on the surface and we shoot the camera, set the emissivity value and do the measurement. So in one case, we have a known temperature. In other case, we have a known emissivity value. There is a very wide application and the emerging application of thermography. One is electrical. If there is an electrical fault at a distance, you are able to find out that the wire is open or there is a fault inside the wire. In coal mines also, because all the metal are at the surface, and if you want to know, by shooting the camera, you are able to find out where you can do the mining. In automobile, if there is any leakage, any crack, you are able to detect by the change in the thermal images. Electronics also, if the circuit is open or closed, if it is not, if there is any fault, you are able to detect by shooting the thermal imaging camera. In mechanical also, by continuously monitoring the system, you are able to detect what kind of fault. In defense application, steel industrial application is very wide for thermography. Steel, cement, paper plant. Particularly in the research area, I have used this thermal imaging camera where we continuously monitoring the system and we get to know the incipient misalignment inside the system by shooting by monitoring the thermal image. the rate of the thermal rise is different with the healthy one. Here also in this refrigerator case study where we use some sort of material to reduce the noise of the refrigerator. So by putting the after putting the material and before putting the material, we do the thermal analysis also, and we get to know by putting the material it is not altering any performance of the refrigerator. Now this I have discussed all the techniques of the predictive maintenance. Now we move into the proactive maintenance. So predictive maintenance is, if you take a simple example, in case of bearing failure, if bearing fail, what we do? We can change the bearing. Okay. So that change the bearing is known as breakdown maintenance. Or if you are continuously if you are doing a preventive maintenance, what actually you do? You after a cycle you change a bearing or you lubricate it or you clean it. That is known as preventive maintenance. Third one is predictive maintenance. You mount an accelerometer on the bearing side, bearing hub, and continuously monitoring the condition of bearing. That is known as predictive maintenance. But here, in all the types of maintenance, we are only talking about maintaining the system, correct? Or maintaining the bearing. We never talk about why the bearing failed. What are the reasons of bearing failure? Why the life of the bearing is so many hours only? Can we improve the life of the bearing? How we can improve the life of the bearing? So those questions can only be answered by doing a proactive maintenance. Here, we are actually looking into the cause of the failure. If we get to know what are the causes, we are also looking into the mitigation of those causes also. So that is actually the fourth generation of maintenance, where not only we are performing the maintenance, we are simultaneously we are eliminating the causes of failure also. So as we all know that different techniques of condition monitoring, ultrasound, vibration, oil analysis, infrared camera, or you can say thermal imaging camera. If it is in breakdown zone, audible noise, it is actually producing some weird noise. The surface is very hot to touch. So this is the region. This is actually, this particular curve is known as performance failure curve, which tells us the sensitivity of each and every technique. Ultrasonic is the first one which gives us a clue about any kind of fault. Next is vibration. Third one is oil analysis, because in oil analysis already the wear is taken place and you are actually looking into the contaminant of that particular wear and finding out the failure. Third one is infrared image, audible noise. But proactive, if you look into the green zone, before the failure begins. So here we are, before the failure begin, we are discussing about the failure and find out the reason of failure or the root causes of the failure and trying to eliminate those root causes. So that is known as proactive maintenance. Proactive maintenance is different from other three maintenance mode because it addresses much more systematic element of a maintenance program rather than examining the machine itself. So it actually focuses on determining the root cause of machine failure and dealing with those issues before failure occurs. Because in other three types of maintenance, we are actually waiting for the failure to occur. But in this, we are finding the root cause before it actually happened. So it is an activity performed to detect and correct root cause of failure. It is the first line of defense against material degradation. It includes routine, preventive, and predictive maintenance activity. So the basic method employed by proactive maintenance to extend item or equipment life. First one is reliability. In reliability, we redesign the system, modify the system, or improvement of part of their replacement. So basically, we're looking into the material side and we redesign, modify, change the material. Suppose if the bearing material is made up of X number of material, and if the life of X number of material is so many years, we can change. If it is made up of plastic, the life of the bearing made up of plastic is so many years. If the bearing is made up of metal, the life of the bearing is different. So in a similar way, if redesign or changing the material composition, we can also increase the life of the product. Failed item analysis. So here also we are doing a failed item. After the failure, like after investigation, to find out what are the reasons of failure. Visual inspecting failed item after removal to determine the reason of failure. Root causes, proactively seeing the basic causes of failure. A specification for new or rebuild item. Once the new item formed, you look into those things and looking into the specification whether the new item is as good as new or the rebuild item is as good as new. Age exploration, it also provides a mechanism to find out the age of the system also. What is the age of the bearing? Rebuild certificate variation at the installation of new rebuild equipment, it is essential to verify, because during the maintenance, the maximum failure occur while installation also, assembly or while installation or while assembly the system. So that also should be verified. Recurrence control, by looking into the failure, we can also control the repetitive failure, because we can change that material with some other material and we can increase the life of the component. Precision rebuild and installation, to control life cost and maximizing reliability, the equipment under consideration require proper installation. So till now, I have introduced you with different types of maintenance. So if I ask you how you are going to perform the maintenance of any cement plant or any machinery or any industrial system, how you are going to do? So you know all the type of maintenance, you know all the techniques. So how you are going to perform? You are just picking out any technique or performing it, or there should be also a systematic way. So that systematic way is known as reliability centered maintenance. Because if we talk about any industrial systems are made up of different component equipment which are characterized by different failure mechanisms. So if you talk about, for a simple example, if you talk about a human body, so you know all the type of operation, surgery and those things, but suppose you know all the medicines also. Suppose a kid whose age is 3 years, we have a pregnant woman, or we have a very old age person, or we have a normal body. Can we prescribe same medicine to all four of them? No. Because why? Because every time we look into the body condition and then the doctor prescribe the medicine. So first of all, doctor asks you what is your body condition. If you have any kind of illness or you have any kind of problem, then he tell you this is the medicine you should take. So in a similar way, all the industrial systems are made up of different components. So different failure mechanism, different reliability. If someone is age of 70 or if someone is age of 3 years, the reliability of both the body is different. In a similar way, looking into the reliability of the industry, looking into the cost of operation, someone is able to pay so much amount to the doctor, someone is not able to pay. So looking into the cost of operation also, looking into the different operational process also. So each equipment need to have a maintenance approach. So this is very important actually. So every time we are actually making mistake by selecting the maintenance strategy. So because first you have to analyze the system, and then as a maintenance engineer, you have to come up with a strategy that this maintenance we are going to perform on this kind of system. So you know all the type of maintenance, but where to perform is very important. And looking into the cost also, by looking into all the aspects also. So each equipment need to have a maintenance approach that is appropriate to its characteristic. So maintenance decision should be based on some strategy which define the component and its failure mechanism. When selecting the type of maintenance, several often contributing conflicting attribute must be taken into account. Mean time to failure, how much time between failure, maintenance mean time to repair, failure cost, budgetary constraints, safety and environment issue, availability of spare part, operator skills. So how we can solve this kind of issue? So this can only be solved by performing reliability centered maintenance. First of all, I must tell you, reliability centered maintenance is not a type of maintenance. It is basically a process of determining the most effective maintenance approach. It employs all the maintenance technique in an integrated manner. look, by performing the reliability center maintenance, we can tell for this type of system, you can perform only one type of maintenance, or you can take an integrated approach of combining two different types of maintenance. So it is actually the umbrella under which all the maintenance comes. It is a process, not the technique, of determining the most effective maintenance approach. A rigorous RCM analysis is based on detailed FME and include probability of failure and system reliability calculation. So FMEA is failure mode effect analysis. It is actually based on analyzing the failure. And once you analyze the mode of failure, you get to know what are the reasons of failure, causes of failure. Once you know the causes of failure, you can tell that this kind of maintenance is suitable. Okay. Suppose you have an industry where you have thousands of pumps. So you cannot perform predictive maintenance to those thousands of pumps. For that, if you perform a failure mode effect analysis, fault tree analysis, you get to know that the culprit one out of 1,000 is 1 or 2 pumps. So there is no need to perform the maintenance also. So reliability centered maintenance is actually give us a answer whether you are able to, whether we are going to perform the maintenance of whole industry or whole plant, or whether to find out the culprit who is actually faulty, who is actually based on the, faulty, who is the reason of the breakdown. Once you know the reasons of the breakdown, then only performing the maintenance on that particular component, not on the whole plant. The question considered by RCM analysis is what does the system or equipment do? What is its function? What functional failure are likely to occur? What are the likely consequences of this functional failure? What can be done to reduce the probability of failure? So here the answer comes in terms of RCM logic tree. So by performing that logic tree, we get to know, will failure of the faculty or equipment have a direct adverse effect on safety? If it is yes, if it is adverse effect on safety, then definitely perform a predictive maintenance. If it is not, then perform a preventive maintenance. If the test of performing a preventive maintenance cost is justified, then fine, do a preventive maintenance. If cost is not justified, then perform a breakdown maintenance. So it's come in like this. First, you have to look into proactive maintenance, then predictive maintenance, preventive maintenance, and breakdown maintenance. So the RCM process is composed of the following steps. First is identify important item with respect to maintenance. As I told you, if you want to maintain a cement plant or paper plant or automobile plant, so first identify the important item. Okay, first break down your whole plant into different groups, and then find out the important item and with respect to the maintenance. Obtain appropriate failure data. Looking into the history of failure, you can also get a clue what is most likely to failure. Develop fault tree analysis, find out the probability of occurrence of failure, apply decision logic tree to critical failure mode, classify maintenance required. Because after you perform a fault tree analysis or FME, you get to know that in a plant, you perform maintenance on 1 or 2 pump, and you are able to achieve the reliability, or you are able to increase the life of the system. Implement RCM decision, reevaluate, or RCM associated default fault. So fault mode effect analysis, failure mode and effect analysis. Failure mode and effect analysis is a step-by-step approach for identifying all possible failure in a design, a manufacturing or assembly process. It is a qualitative as well as quantitative approach. If it extends to quantitative, then a criticality analysis is required. Otherwise, it is a qualitative approach. Here we find out the risk priority number. This is the typical FMEA sheet. Here we find out the function of failure, function of the equipment, what are the potential failure mode, what are those effects, and we rank in terms of severity from 1 to 10. 10 means severe, 1 means less severe. Same as the causes of the failure, how frequently it occurs, same as also we rank the occurrence in terms of 1 to 10. Next is current process control. Are we able to detect the failure easily, or we are not able to detect the failure? Then we can also rank the detection. Multiplication of all three, severity, occurrence, detection, is risk priority number. Then we can find out the action, what action we can take to reduce the risk priority number. Who is going to perform that action? When the action is taken, then again you calculate the new RPM occurrence detection and calculate the severity. So severity, occurrence and detection, it is a qualitative measure to control the worst potential consequences resulting from the function of failure. 1 is not severe, 10 is very severe. Same as 1 is not easy to occur, likely to occur, not likely to occur, 10 is very likely to occur. Detection means able to control or detect the prevent failure, easy to detect, not to detect. Again, you have to calculate the RPM, severity, occurrence and detection, and find out the risk priority number. Criticality analysis. In criticality analysis is based on the standard 1629A, where we know some part failure rate of some part we actually know the failure rate of the data is available to calculate the criticality number. So based on that, by using that particular equation, we can also calculate the criticality of the system also. So if we take an example of bearing failure analysis, you know the failure modes of bearing. High vibration bearing failed. Failure effect is this: overload, overheat, repair, equipment shutdown. Severity is 8. So again, you calculate, give some severity value, occurrence value, detection value, and calculate the risk priority number. So the key is we have to first target the highest risk priority number to reduce the event. So next important technique is fault tree analysis. In fault tree analysis, what we do is here, difference between fault tree analysis is a top to bottom approach and failure mode is bottom to top approach. Something gets failed and you are actually finding out the causes of failure. Here top to bottom approach is something is not working and you are investigating those conditions, why it is not working. So identify the critical event and combination that lead to top event, and your top event is actually the system is not working. Here also we perform two type of analysis. One is qualitative analysis, one is quantitative analysis. Qualitative analysis, finding out the smallest possible combination of occurrence of failure event. Quantitative analysis is calculating the probability of that top event. It is also based on how we do the calculation is based on Boolean logic. You all know that OR gate, union of event of all the gate. A AND gate is intersection of event of all the gate. So here, this is the basic structure of the fault tree. Top one is the top undesired events. Something is not working is known as an undesired event. And we actually intermediate event that system is not working because of so reasons. So here we do that. So if we take an example of electric motor failed to operate. The reason can be defect in the motor, no current in the motor. If circle shows we cannot extend this because we don't have much information about the failure, then here in the rectangle, it's no current to the motor. The reason could be switch open, wire failure, fuse open, power supply failure. In switch open condition also, switch failed to open or switch open by some other reason. Fuel failure because of overload or fuse failure under normal condition. So here like this, we develop a fault tree and find out the reasons of the failure. Now come to the reliability estimation. So in reliability, we have two types of data. One is field data, one is live data. So what we do with the field data and what we do with the live data, the data, if in the field, whatever the data we collect, the data length is not much, then we can evaluate the field by doing a non-parametric analysis. If the data is sufficient, then we can try to fit those data into the distribution and trying to calculate the parameter. So here, if you look into the non-parametric method analyze failure data without assuming any particular distribution. Non-parametric methods are simpler and easier to apply. Disadvantage is sometimes the extrapolation or the prediction of reliability outside the data range is not possible. And the method for conducting non-parametric analysis is Kaplan-Meier estimation, simple actuarial method, standard actuarial method. So there are two, basically what I meant to say is there are two ways to calculate the reliability. One is by not assuming any type of particular distribution, and second is by assuming any type of particular distribution. So these are the ways to estimate. I'm not going into the detail. I'm just skipping that part because looking into the time, I just want to cover few more important things. So second is the parametric method. So first we are trying to fit the data into normal distribution, exponential distribution, Liouville distribution, long normal distribution. And for that also, before fitting it into the distribution, we have to perform goodness of fit test and find out whether the data is going to fit into that particular distribution or not. And once we fit into the distribution, I'm just skipping few slides. So here we calculate the reliability. Once we fit into the normal distribution, we can calculate 4 different parameters that reliability measures. One is cumulative distribution. It is the area under the curve from 0 to t. This is the red one is the probability of failure, and the green one is the probability of success. So probability of failure is known as the unreliability of the system. It is calculated by cumulative distribution function. Next is probability of success, that is known as the reliability. So here, by performing this kind of activity, we are able to calculate the reliability of the system. So first we have to put data, because you have a data failure data, we're trying to fit into different distribution. Once you fit into the distribution, you use those particular equation to calculate the reliability. Okay. So this is the time to failure distribution of this, and how we can calculate the reliability and hazard rate and mean time to failure. This is the second example. I'm just skipping those things. Wait a second. Now, the idea of telling you the failure mode effect analysis or discussing the failure mode effect analysis and fault tree analysis is this. We are actually trying to enhance the availability of sewage treatment plant. As I showed you the sewage treatment plant in my initial slide, so we have performed a case study on this. So how we do that? Because a sewage treatment plant having different sections. It is having a inlet section, physical treatment. Why it is changing? Inlet, physical treatment plant, and different section. So idea is to divide the whole plant. So because in a plant, we don't know from where to start, because there are so many maintenance techniques, there are so many, they're already performing some type of maintenance action. So how we proceed? So what we have done in this particular sewage treatment plant, this is a case study done by one of my master's student. He is sponsored by L&T. So what he has done is he divided the whole plant into different sections. He divided the plant and he acquired some sort of data. So he acquired the failure data from 3 years, for 3 years, 2015 to 2018, and he get to know what are the fault details. He actually acquired all the location, fault detail, and then he developed the FMEA sheet based on that information, and he get to know what is the severity, what is the highest risk associated item. Once he know that highest risk or the highest RPM is because of this particular, in this particular plant, in this section only, then we have to find out the strategy for only that particular section. So we don't have to perform the maintenance activities for whole sewage treatment plant or wastewater plant. So here we have to actually divide the whole plant into different sections, and by doing that, we get to know that this is the severity is on this particular section. Then we have to perform the maintenance on that particular section. So this is the particular outcome of that FME study we have carried out on that plant. So inlet, physical treatment, biological treatment, disinfection system, slush system. So he performed FMEA and FTA. He get to know that in this physical treatment plant is divided into 3 different sections. And in this particular red one shows the critical, actually shows the critical process component, and the failure modes are this. Again, he performed the FT analysis and he confirmed that these are only the critical processes involved in the whole plant. So we don't have to perform the maintenance. Every time I'm saying this because maintenance is associated with cost. So you don't have to perform the maintenance of the whole plant. You have to just look into, find out the risk associated region and then perform the maintenance activities on those things. So these are the root causes of that particular critical process, and we have developed the strategies of those critical maintaining strategies of maintenance for those critical item only. Next case study is failure and performance analysis of surface miner. I have showed you the surface miner in beginning. So surface miner is also one of the important mining equipment which is used for excavating the coal and other mineral from surface. So this also case study performed by one of my L&T student, and this case study performed on the Coal India site where this surface miner is facing unexpected breakdown. So as a maintenance engineer, what is our first thought? Our first thought is breakdown, why it is not able to produce, why the production rate is less because of unexpected breakdown. Okay, so we thought so, because as a maintenance engineer, we always thought there's something happened to the machine. So once we have done the failure mode effect analysis, FME analysis, finding out the root causes of the failure, looking into the performance analysis, the overall equipment effectiveness is only 35%. Okay, so we get to know the required value is 45 to 60%, but the average value is 20 to 30% only in month. So we want to know what is the why it is not performing its intended function. So we have done FME analysis, FT analysis, performance analysis, where we find out the operational availability, utilization factor, production index or efficiency, and find out the overall equipment effectiveness. And we get to know that the actual value is actually below. Why it is below? The reason could be, the actual reason is not the maintenance issue. The actual reason is something different. The production loss in percentage, 44%, is because of hardness of soil and coal, surface leveling condition, water logging due to groundwater, machine get weakened with age due to fatigue, night shift machine run with maximum safety. 38% loss because of administration, operators are not available due to change in shift, no fuel available, labor union strike, improper leveling, no approach to reach machine due to ground, lunch break or tiffin break, non-availability of proper infrastructure like road. Technical wrong. So we are actually contributing into technical loss only, and the technical loss is only 10% due to poor maintenance, lack of proper inspection during maintenance, poor quality, unavailability. So in that kind of scenario, if without performing the FMEA or FT or any root cause analysis, if we are going to perform, we are doing the maintenance, so actually we are going to add the cost, and which is actually not required, because here the loss is not because of technical or the maintenance issue. Here the loss is because of some other reason. So that is the reason I must tell you why FME, FTE, root cause analysis, proactive maintenance, RCM is important to us. Now I am moving again back to condition monitoring. So why I just want to tell you what are the emerging trend in condition monitoring. You all know the techniques of condition monitoring. You have learned different techniques of condition monitoring also. You know all the different maintenance techniques also: preventive maintenance, predictive maintenance, breakdown maintenance, and condition-based maintenance also. You know RCM also, when to perform maintenance, you also know. But now the challenge in the maintenance is this, because we all know that rotating machine is not composed of one bearing or two bearing. In industry, if we talk about a big plant like cement plant, thermal power plant, a gas turbine used to power frigate, railway engine, there are number of components. And if you are going to perform predictive maintenance, so for that you have to mount sensors at different location. If you are able to mount sensors also, how you are going to, if you acquire the signals out of that sensors also, how you are going to manage those data? So the main problem nowadays, what we are facing is managing the data. Okay, so we have done lots of advancement in the sensoring also, but how to manage those data, because data is on the cloud. Here you have to look into the data, do the analysis. So if you look into that, if you look into the heavy equipment also, there are a number of components. So here also managing the data is a very big challenge because those machine is at very remote location. And who is going to perform the vibration analysis? Who is going to look into the thermal imaging? Who is going to look into the oil monitoring? So those are the major challenges. So for that, the proposed system is to use state-of-the-art technique that is known as machine learning technique or artificial intelligence approach with some statistical technique. And with that, we are able to reduce the optimized data set. And it will also use less memory, quick decision making, soft computing techniques. So basically, integrate the traditional approach with some advanced approach that is known as machine learning, cloud computing, IoT, and find out a smart, intelligent, automated fault diagnosis system. To develop a smart, intelligent, automated fault diagnosis system. So here, because nobody want to stand with the machine nowadays, people have to perform with a very remote location. So for that, can we develop those kind of system which can automatically monitor the system condition? So for that, the fault detection strategy should be composed of some traditional techniques, that is vibration monitoring, temperature monitoring, current monitoring, and with some state-of-the-art technique that is using the fault classification technique based on artificial intelligence, or using some statistical technique that is based on a principal component analysis, or so on. So here, if we have a small system like this, if we have a machine fault simulator like this, we can introduce the system with different fault conditions because that is in our control. So if we develop a system at very small stage or the laboratory level, can we implement the same strategy to the advanced level, that is at the industry level? Yes, we can do that. So we have to develop those kind of system which we can develop at the laboratory level and implement at the industry level also. So here this particular system can be introduced with different bearing defect, misalignment, shaft defect, gear defect, in eccentric rotor, different types of coupling, different types of unbalance. So we develop the system by introducing the system with different fault condition. Once we introduce the system with different fault condition, we mount number of accelerometer also. So because ultimately the idea is to reduce the data handling part. So initially we mount number of transducer, and then we try to find out how to reduce those number of transducers also. So these are the condition with load, without load we have formed. So these are the angular misalignment we have introduced by introducing the shim. Here also parallel misalignment we have introduced. Rotor unbalance we have introduced in the system. Unbalance by adding in the mass to the system. Next is we have eccentric rotor also. One is normal rotor, one is eccentric rotor. Next is in system we introduce a system with cracked shaft. By opening and closing of the bolt, we can introduce the severity of the crack to the system. Bearing, we have defected bearing. One is inner race defect bearing, outer race defect bearing, ball defect bearing. So we have different defected bearings, and we have a defected gearbox also. And this is the reason-based technique we have developed. So we can, if in normal condition, we can do this kind of vibration analysis where we can find out where we can look into the characteristic frequency, 1x, 2x, harmonics of those things, and we can find out the fault. But I'm not talking about the basic vibration-based technique. I'm talking about an automated system where we don't require any kind of person to look into the characteristic frequency. We want system itself to classify the fault and find out what kind of fault is there in the system. So by introducing the system with different kind of fault conditions, we have developed some reason-based fault diagnostic chart that is actually based on vibration analysis. By putting load to the system, by running the system with different frequencies also, we are able to develop this kind of traditional approach-based vibration-based severity chart. And then here we have also performed the temperature monitoring, because in a system, sometimes we are not able to perform contact type of measurement. So we can also acquire the data by non-contact type of measurement. Or here also we have a laser-based vibration monitoring system. laser vibrometer, where we can, at a distance, we can find out the vibration of the system. So my idea is not about here the instrumentation is. Here you can use any type of instrumentation, contact type of instrumentation, non-contact type of instrumentation. Here in this particular thing, I want to tell you that once you have acquired the data from any sensor, whether it is a temperature monitoring, whether it is a motor current monitoring, whether it is any kind of sensor, once you acquire the data, what you can do is, it's a misaligned system. So once you can acquire the system, it is a normal condition where you can check the data at any instance. If there is any fault, so we are able to classify the fault by using support vector machine, or nowadays you can use any different types of fault classification technique. If the machine is okay, you can perform the statistical analysis and find out the effective transducer, because initially we mount number of transducer, that is contact type of transducer, non-contact type of transducer. But here we want to reduce the coherent transducer, incoherent transducer, and we want to reduce the number of transducers also. So by using the statistical technique, principal component analysis, we can reduce the incoherent transducer to find out. Again, once you are able to reduce the number of transducer, you can perform the reason-based strategy for actual fault detection. So for the feature extraction, we have used principal component analysis. Yes. Compensation distance evaluation techniques are used for feature selection also. And again, based on that statistical ways, as well as using the machine learning approach that is known as SPM, we are able to classify the fault. So this is one particular case study I have published in long back in 2014. But nowadays there are number of ways to find out. Number of fault classification techniques are available. Number of feature selection techniques are available. You can use the advancement of the machine learning technique to the condition monitoring approach and find out and to develop a automated fault diagnosis system. So this is how we have done that part. I'm skipping that. I'm just showing you the application of machine learning. So machine learning is proved to be a very powerful tool to manage the huge fault data efficiently to diagnose the failure in rotary machine. Deep learning is also people are using for development of fault diagnostic system. Deep learning is a rapid improvement of machine learning algorithm, which found it plays as an efficient way for overcoming these limitations of machine learning. Nowadays, transfer learning is a research problem. As I told you, suppose something you have developed at the laboratory level, like I have developed some sort of fault classification techniques. I have done some sort of fault identification technique at machine fault simulator at laboratory. But can the similar approach can be used for industrial system? So for that, transfer learning is a challenge what we are facing right now. It is actually a research problem in machine learning that focuses on storing knowledge gained while solving one problem at the laboratory level and applying it to a different but related problem at a bigger level. So the major challenge now we are facing in condition monitoring, or the major future of condition monitoring, is to use machine learning development of automated fault diagnostic system. So if you look into the vibration monitoring also, we have a test bearing, we can acquire the data, we have a raw data. So here in raw data, as I told you, sometimes time domain feature is not able to give a clear picture about the fault. So here in machine learning, you can use that time domain feature without converting it into frequency domain. That is the way also you can use machine learning approach. You can only train the time domain data and classify the fault. You can train the frequency domain data and classify the fault. You can extract the time frequency domain feature and classify the fault. So there are various methods now open up because of advancement in machine learning you can do. And if we talk about, see in the vibration monitoring, we can do by using the machine learning. Here we have trained the time, we have extract the time domain feature And based on that, we are able to find out the multi-domain bearing fault diagnosis using support vector machine. Next is technique can be vibration monitoring. It could be motor current signature analysis. It can be thermal imaging camera. Similar approach can also be used with motor current signature analysis also. Acquired the data, we have the raw current signature, convert into short time Fourier transform, extract the feature, look into the sliding window based feature extraction technique. So there are a number of things. I'm just giving you a glimpse of different techniques. If you want to look into the more detail, you can look into the below paper for more detailed information. We can extract the feature vector, we can train. Here we have a different techniques also, fault classification techniques also, performance evaluation. So we can use motor current, we can apply in machine learning to motor current signature analysis also. If we talk about, see, this is a sensor, Hall effect sensor for acquiring the current signature. So here, motor current signature analysis can also be used for multi-sensor fault diagnosis for misalignment and unbalanced detection using machine learning. Here we are fusing two different types of data. One is vibration data, one is current data. And to increase the reliability of the system, because one data shows a certain classification rate, second data shows certain classification rate. Once we fuse both the data together, we can get more reliable, we can develop more reliable system also. Here we have used the deep learning approach where we can use the image, not the data. With image, we are actually pre-processing those image, find out different patterns, and based on that, we have done the feature extraction of those images. And with that feature extraction, we have performed some principal component analysis, feature reduction techniques, and then fault classification things. So I'm just giving you different, I'm showing you the source also. If you want to look into the detail, you can look into those details, how we use infrared thermography, motor current signature analysis or vibration technique, and how we fuse it with machine learning and what we actually get. So here also we have used infrared thermography, looking into the CNN, computational convolution neural network based bearing for diagnosis of rotating machine using thermal imaging. So here we extract the images, pre-processing those images, feature extraction, feature selection, applying artificial neural network, applying CNN, ANN, SVM. So like this, we can also do the condition monitoring. So this is the infrared image of healthy motor with load, motor with rotor broken bar, ball defect bearing, lack of lubrication. By looking into the image and extracting the feature out of that image, we are able to detect what are the severity of the failure. This is the system. Infrared thermal imaging cameras has been used to develop a convolution neural network based bearing for diagnosis of rotating machine. So this is, I guess, the last slide of my presentation. Here we are also trying to use this intelligent mini coin, or you can use you can say sound quality parameter to diagnose the fault. Because sometimes if we talk about, if we have a fan bearing failure, so the person can, by listening the sound of the bearing, people can tell there is a lack of lubrication or bearing having some sort of problem. So people are able, by hearing also, people can make some sense about the fault. So this intelligent mini coin, or you can say sound quality system, can also hear the sound of the machine. And by listening those sound, if there is a bearing failure, if there is a misalignment, unbalance, by using some advanced features of sound quality, this is also the ways to find out, to diagnose the failure inside the system. So looking into the harshness of the sound, looking into the tonality, looking into the roughness, prominence ratio, people can tell what kind of fault is there in the system, whether it is on the bearing side, whether it is on the gearbox side, whether there is a fault inside the motor. Okay, so we have to train the system by using this intelligent mini coin or machine learning approach also. So Here also the research is going on in multi-sensor fusion, where we are fusing the two different sensor and trying to develop a more reliable system. Vibration thermography based sensor are used and multi-sensor fusion is adopted for enhanced reliability. Multi-sensor fault diagnosis for misalignment and unbalanced detection using machine learning. So this is also the ways of sensor fusion also. Okay. So fuse the data, pre-processing those data, feature extraction of both the data, feature fusion and feature selection, then fault classification. Now the important thing is Internet of Things, that is IoT based support. Suppose the system is at very remote location. So if we at the place, if we are able to reduce the data by applying some statistical technique or machine learning technique, and we can only send the relevant feature to the cloud and acquiring those cloud at very office, and we are able to find out the fault in the system. So it is an accurate measurement. Measurement are prone to error. Instant notification you can get, reduce unnecessary shutdown, refine maintenance schedule with a record of part and machine life cycle. You can tailor your repair to reflect actual wear and tear. Greater efficiency, machine monitoring give you the information you need to balance line and time production, no manual data entry, simplified performance reporting. So nowadays we can develop some sort of app for fault diagnosis also. So in your mobile phone, if you are not at the industry or you are not available at the plant, you still get notification. So we are trying to develop those kind of technique where we can still get a notification that your system is going to fail at your mobile phone. So similar way of alarm we are trying to develop by using all different types of techniques, signal processing as well as machine learning, and using the approach of Internet of Things, so that we can have all the information at our at the mobile. So this is the application of Internet of Things to condition monitoring. Thank you. I hope I am on time. If you have any question.
Thank you, ma'am.
So if you want to know more about the things, you can look into my web page also. This is AHM, Automotive Health Monitoring Lab at IIT Delhi. So this is the recently inaugurated lab by our director, sir. You can look into the number of research we are going in terms of condition monitoring and NPH. We have a different setups also. You can look into the equipments also. So this is AHM Lab, Automotive Health Monitoring Lab at Center for Automotive Research and Tribology, IIT Delhi. Yes, please. Hello. Yeah. Hello. I'm audible. Hello.
Yes, Dr. Fatima.
Yeah, I'm audible.
Yes, you're audible. Yes, you may please continue.
Hello.
Done any questions from the panel side? From student side, any questions?
Hello.
Yes, please.
Hello.
Yes, you are. Hello, I'm not able to hear anything.
Yes, Dr. Sudhir, can I say something? Hello.
Yes, please. Yes, please. I'm listening.
Okay. Thank you, ma'am, for your nice lecture and very informative lecture the maintenance of machines and equipments. So I learned a lot about the breakdown maintenance, preventive maintenance, proactive maintenance, and maintenance. Also, one very simple question. In laboratory, we have various types of machines, and we have these machines. So, what type of maintenance would you suggest apart from these annual maintenance of our laboratory equipments?
Yes, that
Since
is
we talked a lot
that is the
about the
reason I
various types of maintenance.
correct. That is that is actually the reason I told you, because everybody, every system have different maintenance approach.
Lot of
So
equipments. Yes.
yes, I'm audible.
If we take, yes, you are audible.
Yeah. See, that is the reason I told you that everybody have different types of approach. So looking into your equipment, looking into the failure modes of those equipment, see, you are doing some sort of yearly maintenance or monthly maintenance. That is actually you are performing a preventive maintenance. How frequently you are
Yes,
using
yes.
those equipment? So before telling you what kind of maintenance approach you should use, I have to look into the system. What system actually you are talking about? How frequently you are used? How much money you are able to spend on those kind of system? What kind of monitoring is actually required? Whether the system is in critical conditions or essential or general purpose? So there are so many questions I have to ask you before telling you that what kind of maintenance approach you should go. It's not a direct answer, a direct question or direct
Okay.
answer I can give you, because like a doctor asks you what is your body condition, how you are feeling, and then he diagnoses you. So in a similar manner, I have to look into everything, then I should tell you what are the failure modes of those equipments or machinery. Okay, I hope I have given your answer.
Yes. I
Yeah, yeah, you
about
look
the
into many
yes,
things, many things.
types of
I must tell you, the old way of doing the maintenance is just pick a technique and just perform that technique on the system. That is the old way of doing maintenance. I'm talking you about industry 4.0 or 5 to how to do an advancement in maintenance approach.
so okay, that machine and transfer learning and
Correct.
traditional maintenance.
Correct.
Right now, I don't have any question in the chat box.
So if someone
Looking
has
in the
any
chat box.
question, someone has any question related to my presentation, they can drop me at my email ID also.
Right now, I think end up here because we are not having any questions. So participants, if they have any questions, they can drop the email. And the should stop our session over here. So before ending the session, let me thank the distinguished speaker, Dr. S. Fatima Madam, for their very interesting and informative lecture on the stability document in the various techniques, techniques for systems and machines. So, Thank you for your
Voice is breaking. I'm not able to hear you properly.
There is a
Professor, voice is breaking.
The announcement is that the next session will start actually, madam. There is one I also not getting my speaking. Hello.
Yeah, your voice is breaking. I'm not able to hear you much.
So here all the participants. Okay, that